For more than a decade, the simplest headline in human origins has been repeated so many times that it is now assumed to be an established fact. Humans left Africa between 50 and 70,000 years ago in a single migration that populated the rest of the planet. However, this is not what the studies actually demonstrated. The real picture is both more interesting and more complicated. The combined genomic, climatic and archaeological evidence points not to one clean event, but to at least three distinct stages in the formation of non-African humanity. First came the split between African ancestors and the lineage that would later give rise to all populations outside the continent. Then came a severe reduction in population size, the so-called out-of-Africa bottleneck. Only later did the descendants of that bottlenecked group divide into multiple continental branches, including the lineage eventually leading to Aboriginal Australians. The popular story is misleading because it collapses these three episodes into a single simplified date. It also ignores another key discovery. A small but meaningful fraction of modern Australian genomes, about 2%, derives from an even earlier dispersal of anatomically modern humans, as early as 120,000 years ago. Some geneticists have argued that this 2% does not matter. Others argue that it absolutely does, because that ancestral piece represents the earliest successful wave of our species outside Africa that contributed to living peoples. This deeper chronology matters not only because it changes the timeline of our species, but because it reframes the geography and environment into which early humans moved. Climate scientists note that the period around 60,000 years ago, often cited as the time of the out-of-Africa migration, was one of the worst imaginable windows for long-distance travel, as northeastern Africa and Arabia were dominated by extreme drought. The most favourable periods for crossing were much earlier, especially around 100,000 years ago. Ironically, it is precisely those earlier windows that align with the mystery ancestry found in modern Papuans. The simplified narrative that most non-Africans descended from a single wave 50 to 70,000 years ago, or 60,000 as is often cited, contains a partial truth, but the details matter. The original studies themselves make clear that the 60,000-year figure refers to the bottleneck, not the split from Africa, which occurred far earlier. The actual split between African and non-Africans occurred around roughly 127,000 years ago, with a range extending from 83,000 to 170,000 years ago. What happened around 50 to 70,000 years ago was not the initial exit, but a contraction of the out-of-Africa lineage followed by later expansions. This means that the headline, "Humans left Africa in a single wave 60,000 years ago," is demonstrably wrong. The genetic modelling underlying the studies clearly separates three major events in the ancestry of non-Africans. The first is the split between Africans and the ancestral ghost population to all non-Africans, estimated at about 127,000 years ago, with a broad plausible range between 83,000 and 170,000 years ago. This is the foundational divergence in modern human history, the moment when a subset of the African population separated genetically from those who remained. This alone shows that the migration narrative has deep roots and cannot be pinned to a single departure 72,000 years ago. The second event is the out-of-Africa bottleneck, estimated at about 72,000 years ago, but with a very large uncertainty spanning 60,000 to 104,000 years. A bottleneck means that the non-African ancestral population shrank dramatically before re-expanding, leaving a strong genetic signature. Crucially, this contraction occurred after the African-non-African split. The bottleneck does not define the beginning of the migration. It reflects what happened to one branch of humans after that branch was already distinct. The third event is the division of the non-African population into regional descendants, in particular the split of the ancestral Australian Papuan lineage from the ancestors of Eurasia around 58,000 years ago, with a range between 51,000 and 72,000 years ago. Only after that separation do the ancestors of indigenous Australians continue into Sahul, the ancient supercontinent of Australia and New Guinea. Because these three events happened at different times, no single date can stand for the entire process. Yet the popular media condensed all three into a single claim. Humans left Africa between 50 and 70,000 years ago. Worse, the press often reported the 72,000-year bottleneck as if it were the split from Africa, which it was not. The critical error is treating distinct events as though they were one and the same. The split is not the bottleneck, and the bottleneck is not the later regional divergence. Conflating them collapses a complex sequence of historical events into a single headline that erases nuance. One of the three studies detected a clear genomic signal in modern Papuans, consistent with an early expansion of Homo sapiens out of Africa, dated to roughly 120,000 years ago. This early wave appears to have contributed at least 2% of the Papuan genome. 2% is small, but it matters profoundly, because it is not noise. It is ancestry. If confirmed, it means that the earliest out-of-Africa population did not vanish completely, but rather survived and became part of the ancestral fabric of some modern humans. Some geneticists, including Joshua Akey, say that the 2% does not matter in practical terms because 90+% of non-African ancestry derives from the later, larger dispersal. But this is not a persuasive argument. A minor ancestral component does not become irrelevant simply because another component is bigger. Aboriginal Australians and Papuans may retain only a fraction of this early ancestry, but that fraction represents the earliest known successful migration of our species. Its survival is evidence that modern humans were moving out of Africa well before 72,000 years ago, and that the population history of Australasia was shaped by these deeper roots. Dismissing the 2% because it is small would be analogous to dismissing Neanderthal or Denisovan ancestry because it accounts for only a limited percentage of the genome. Yet these small genetic introgressions revolutionized our understanding of human evolution, revealing admixture with archaic hominins. In the same way, the 2% early modern component signals the presence of an overlooked chapter in human history. The early population may have moved across Arabia and into southern Asia during favorable climatic windows between 100,000 and 80,000 years ago. Their descendants would later be joined or absorbed by the larger wave that produced most modern non-Africans. One can therefore accept both that most ancestry comes from the later wave and that the earlier wave contributed to living populations. The two models are not mutually exclusive. In fact, archaeological finds of early modern human remains in Arabia, China and Southeast Asia, older than 70,000 years, fit naturally within this model. The early genetic contribution also implies something more subtle. It suggests that the out-of-Africa process was gradual, complex and regionally dynamic, rather than a single once-off dispersal. Genetic traces of the early migration survived overwhelmingly in Australasia because it lay at the far end of the migration corridor. Other regions received subsequent waves that swamped earlier genetic signatures, but remote Australasia protected these fragments, preserving echoes of the very first non-Africans. Another line of evidence contradicts the simplified 72,000-year story. Climate simulations modelled by Dr. Alex Timmerman reveal that 60,000 to 70,000 years ago was the worst possible time for humans to exit Africa.
You can see actually we had several migration waves out of Africa. I don't like the word out of Africa. I will say into Eurasia instead. So we had several major waves. In fact, the time period, which is very often used by geneticists, 60,000 years for the divergence, is probably not really climatically a very good time period, because this was a period where northern hemisphere summer was farthest away from the sun, so it was extremely dry in the northern hemisphere, and at the same time also the Atlantic circulation collapsed, which creates very dry and cold conditions. So you can see this is really the worst time actually to migrate. However, after 60,000 years, you have a situation where, again, Earth's axis changes, and we are moving the northern hemisphere somewhat closer to the sun, making it warmer and wetter. And then you can see actually this is also not just one pulse, but we see many of this one. It looks like the entire dynamics is chopped off into these smaller periods, which are actually generated by the flickering of the Atlantic meridional overturning circulation, driven by ice sheet instabilities. So you can see also on a shorter time scale, and that's relevant, of course, for human adaptation as well, we can see these variations in climate driving changes in the density of humans and this flow of humans into Eurasia.
Northeastern Africa was extremely dry and inhospitable, and the Arabian Peninsula was largely closed. The environment was hostile, food would have been scarce, and corridor routes would have been blocked by desert. In contrast, a series of earlier periods, roughly between 107,000 and 95,000 years ago, and again around 90 to 75,000 years ago, provided wetter climates and lower sea levels that would have made migration far easier. During these windows, humans could have crossed into Arabia without difficulty, following green belts of grasslands and rivers. This climatic evidence aligns closely with both archaeological finds and the early genetic signal detected in Papuans. It indicates that the earliest expansions likely took place under favorable conditions, long before the bottleneck. In this scenario, the bottleneck does not represent the beginning of dispersal, but the narrowing of an already established lineage. The climate data therefore supports a picture in which modern humans dispersed gradually, moving back and forth across northeastern Africa and Arabia, mixing and remixing until drought sealed the boundary around 70,000 years ago. That closure created a stable genetic divide between Africans and non-Africans. When later expansions occurred, they left a strong genetic signature that is easy to detect today. Earlier movements diluted into Africa or left only faint traces, except in regions like Papua New Guinea where they survived. This does not mean that the later migration was insignificant. It was massive, and it contributed the majority of ancestry in non-Africans. But its success does not erase the evidence for an earlier chapter when humans were moving across continents while climatic gates were open. Despite the complexity outlined in the original research, media coverage boiled the findings down to a simplified message. Almost all non-Africans trace their ancestry to a single migration event more than 50,000 years ago. Some headlines claimed the wave occurred 72,000 years ago. Others said 52,000. Still others split the difference. Nearly all presented the date as if it were the one and only moment when humans left Africa. This simplification conflates the split, bottleneck, and later branching into one. It also ignores the huge uncertainty ranges. The bottleneck could have occurred as early as 104,000 years ago. The African non-African split could have occurred as early as 170,000 years ago. If the split occurred 170,000 years ago, this has profound implications about human evolution, yet these ranges never appear in news reports. The public is instead given a date that is both false and overly precise. This narrative also encourages a misleading image. It suggests a single heroic moment when a solitary group marched out of Africa into the unknown, replacing all others in an ancient manifest destiny. The reality, by contrast, is a long episodic process that unfolded during shifting climatic pulses, where earlier groups ventured outward, mixed, vanished, or endured, and where later groups expanded and absorbed the remnants of those before them. The media also downplayed the 2% early genetic signal, often burying it beneath statements about a single wave. When quoted, some scientists dismissed the early component as negligible. But the presence of earlier ancestry in Australasia is scientifically significant because it shows that early dispersals were not only real, but successful. They left descendants alive today. The headline, "Single out-of-Africa migration gave rise to today's non-Africans," is not entirely wrong, because the overwhelming majority of ancestry does come from a single major expansion. But without noting the earlier event or distinguishing between the split, bottleneck, and branching, the sentence becomes misleading. The deeper three-stage framework places modern humans within a richer evolutionary context. The first stage, the split between African and non-African lineages, anchors the origin of non-African peoples long before the bottleneck. The second stage, the bottleneck, represents not an origin, but a demographic drama confined to a branch already outside the Central African population cluster. The third stage, the divergence of the ancestral Australian group from the ancestor of Eurasia, marks the beginning of continental expansions rather than the initial departure from Africa. Under this interpretation, the 72,000-year date has meaning, but it signifies a population contraction and genetic narrowing within an already distinct out-of-Africa branch. It is only one chapter in a longer history that begins at least 127,000 years ago and involves early waves that left genetic descendants. This model also aligns with archaeology. Early modern human remains in Arabia, Israel, and East Asia predate 70,000 years ago. These fossils make sense only in a scenario where humans repeatedly dispersed out of Africa during favorable climate windows. The earliest waves may have been small and vulnerable, but not all vanished. Moreover, this framework enriches the story of Aboriginal Australians and Papuans. Their ancestors did not simply sprint ahead of everyone else during a single dispersal. Instead, they participated in deep population processes stretching back beyond 100,000 years. After the bottleneck, the Australian Papuan lineage diverged early from the rest of Eurasia. Their later journey into Sahul preserved genetic memories of the earliest expansions. This three-stage sequence clarifies why Australian populations today contain both the dominant ancestry from the major dispersal and the faint but real signature from an earlier migration. The true story of human migration out of Africa is one of intermittent expansion, climate-driven pathways, multiple pulses of exploration, and partial survival of early branches. It is not a single clean sweep. The genomic signal of the bottleneck is strong, but it does not mark the first steps into Eurasia. The African-non-African split predates the bottleneck. The earliest dispersal may have contributed only 2% to modern genomes, but that 2% is the footprint of the earliest modern people outside Africa who left descendants still alive today. The misconception comes from reducing a complex sequence into a headline. When journalists write that humans left Africa 72,000 years ago, they are translating a bottleneck date into a departure date. When they claim there was a single wave, they are technically describing the dominant signal while ignoring the smaller one. The better framing is this. Modern humans began diverging into African and non-African lineages roughly 130,000 years ago. Some of these early people likely left Africa during climatic windows between 180,000 years ago, reaching regions where their genetic traces can still be found. A later demographic contraction around 80,000 years ago narrowed the non-African lineage. Afterward, this lineage expanded and branched, giving rise to Eurasians and slightly earlier, the ancestors of Aboriginal Australians and Papuans. Only this narrative accommodates the full spectrum of evidence: the genetics, the climate reconstruction, the archaeology, and the human remains outside Africa, older than 70,000 years. The story of how humans left Africa is not an easy timeline, but a layered one. It is tempting to simplify it for the sake of clarity, but overcompression distorts reality. The 72,000-year figure refers to a bottleneck in the lineage that would become non-African, not to the original departure. The deeper split between Africans and non-Africans occurred much earlier, around 127,000 years ago. An even earlier expansion, perhaps 130,000 years ago, left a small but meaningful trace in Papuan ancestry, showing that early explorers did not vanish without a legacy. These three events are not interchangeable. They represent different chapters of a complex story. The media's insistence on a single wave between 50 and 70,000 years ago obscures important variation and minimizes discoveries that change our understanding of how our species populated the world. The early 2% component matters because it restores to the record the earliest known modern humans outside Africa who contributed to living peoples. Its survival challenges the idea that only one wave existed. The climatic evidence reinforces this view. The best windows for movement were far earlier than 70,000 years ago. The unifying conclusion is that human expansion was gradual, multi-phased, and driven by opportunities and hardships in a changing landscape. Humans did not burst out of Africa 60,000 years ago and conquer all of Eurasia in a single wave. Click on these other videos to learn more about our human journey, and thank you for watching.